Hi to all. Some electrical measurements multiple choice questions, that is MCQs, we'll see in this video. Coming to first one is the input impedance of a voltmeter is A high, B low, C medium, D zero. For this voltmeter, what is the input impedance? In order to prevent the loading effect in a voltmeter, if you connect the voltmeter for any circuit, if any loading happens, then circuit will damage or circuit will short circuit. The input impedance is maintained as high as possible. It must be maintained higher than the impedance of the circuit being used. Whatever be the circuit where we are connecting, the whole circuit impedance, if you consider the voltmeter have more impedance, that is a high input impedance a voltmeter have. Coming to second one, in DC circuits, power is measured using A ohmmeter and galvanometer, B ohmmeter and voltmeter, C ammeter and voltmeter, D ammeter and galvanometer. Here ohmmeter used to measure the resistance, galvanometer used to measure the current. A bit is B is ohmmeter and voltmeter, C ammeter and voltmeter. An ammeter is used to measure the current flowing through a circuit, while a voltmeter is used to measure the voltage across the circuit. Hence, for any DC circuit, ammeter and voltmeters are used to measure the power. Hence, C is the correct answer. Coming to third question, in AC circuits, power is measured using A voltmeter, B ammeter, C ohmmeter, D wattmeter. Voltmeter, ammeter and ohmmeter, what is the purpose? Voltmeter used to measure voltage, ammeter used to measure the current, ohmmeter used to measure the resistance, whereas D wattmeter used to measure the power. In AC circuits, make the use of power factor of the circuit in addition to current flowing through the circuit and the voltage across the circuit. As a result, a wattmeter is used to measure AC power. Hence, the answer is D wattmeter. Wattmeter is used to measure the power in AC circuits. The next question is pressure coil of a wattmeter. A has capacitance and inductance, has inductance and resistance, C has resistance and capacitance, D has only inductance. The pressure coil, also known as potential coil, and it is connected across the source. A series resistance R consists of inter-turn capacitance. As a result, the pressure coil of wattmeter consists of capacitance in addition to inductance. Every pressure coil of wattmeter, it is connected across the source, across the voltage source. The pressure coil is moving coil in a wattmeter. It has a resistance. It consists of number of turns. The resistance has number of turns. Between the turns, an inter-turn capacitance will appear. Hence, the pressure coil or potential coil of a wattmeter has capacitance and inductance. The answer is A, has capacitance and inductance. Coming to next one, induction type instruments are used for A, AC measurements, B, DC measurements, C, resistance measurements, D, voltage measurements. There are so many types of instruments. Among those induction type of instruments, AC measurements are made using induction type instruments. Induction type energy meter is used to measure the energy that is consumed in AC circuits only. Hence, induction type instruments are used for AC measurements only. Induction principle involved in only AC measurements. Hence, AC measurements are possible by using induction type instruments. Answer is A, AC measurements. Coming to next question. The copper shading bands are placed as a resistance, B placed as a wire, C placed as outside of the central limb, placed around the central limb. The copper shading bands used to lead lag adjustments. Copper shading coil consists of many thick turns or thin turns, that is thin turns, on the central limb of shunt magnet of energy meter. We can make the use of shading coil. The shading coil consists of a few fairly thick turns. The figure below shows a shading coil on the central limb of the shunt magnet. Hence, the copper shading bands are placed around the central limb. Hence, D is the answer. Coming to next question. Creeping in energy meter is avoided by A. Reversing the polarity of voltage, B. Drilling the two diametrically opposite holes, C. Holding the disc, D. Increasing the friction. What is meant by creeping? In energy meter, creeping causes the disc to rotate even when there is no current flowing through this energy meter. By drilling two diametrically opposite holes under the edge of the pole of a shunt magnet, rotation of the disc is limited to a minimum value. Hence, the creeping is avoided by drilling the two diametrically opposite holes. That is, answer is B. Drilling two diametrically opposite poles on the disc of a energy meter, the creeping can be avoided in energy meter. The eighth question is, two wattmeters which are connected to measure the total power on a three-phase system supplying a balanced load reads 20.5 kilowatt and minus 3.5 kilowatt respectively. What is the total power? A. 13.0 kilowatt, B. 17 kilowatt, C. 15 kilowatt, D. 19 kilowatt. The wattmeter 1 reads 20.5 kilowatt, whereas another wattmeter it is a negative reading minus 3.5 kilowatt. Therefore, total power is given by W1 plus W2 equal to 20.5 minus 3.5, that equal to 17 kilowatt. The answer is B, 17 kilowatt. We have to add the two wattmeter readings, 20.5 plus minus 3.5. Hence, 20.5 minus 3.5 gives 17 kilowatt. B is the answer. The next question, moving coil, PMMC and moving iron instruments can be distinguished by observing A. Range, B. Scale, C. Size of terminals, D. Pointer. The PMMC instruments and moving iron instruments, that is moving coil and moving iron instruments, can be differentiated or distinguished by observing not the range, not the size of terminals, not the pointer, the scale. The scale is uniform for PMMC instrument, that is moving coil instruments, whereas moving iron instrument, the scale is non-uniform. It is linear up to some portion. After that, it varies. Non-uniform scale will observed in moving iron instruments. By observing the scale, we can identify it is a moving coil or moving iron. The answer is B, scale. The next one is, in electrodynamic instruments, the operating field is produced by A. Permanent magnet, B. Fixed coil, C. Moving coil, D. All of this. Electrodynamic instruments, in the sense, those are electrodynamometer type instruments. The electrodynamometer type instruments are provided with fixed coil and moving coils. There is no permanent magnet in electrodynamometer type instruments. Hence, the fixed coil is divided into two parts, that is two halves. The fixed coil is divided because of to produce more uniform flux, that is operating field is produced by fixed coil, which is divided into two halves. The moving coil is not producing operating field. The deflecting torque is produced in moving coil. The electrodynamometer type instruments already you've seen in the previous lessons. The electrodynamometer type operating field is produced by a fixed coil which is divided into two parts. Hence the answer is B, fixed coil. Fixed coil is the answer.